Hello, this video will give you a quick overview on what you can do with cppHeaderGen. If you're searching for a quick start guide, this video is for you. Let's first check out all the files we got. Printer.cpp here is for the class we're going to create. I will explain this one later. cppHeaderGen.h enables the extended syntax of cppHeaderGen within C++, and cppHeaderGen is the actual generator. On Windows you would have cppHeaderGen.exe. That being said, let's go into coding. We will create a new class, printer. This first line here tells the C++ compiler that we use the extended syntax of cppHeaderGen. Of course, usually you would have to set up a proper path here, but as all the files are in the same directory, we just can use it like this. This line here defines a new class, and this line here defines the end of the new class. Now let's generate the header file. You simply call the program with the file name as an argument, and let's open up our file manager to see what's happening, and we got indeed a printer.h here. Let's close this down and add this here and put this side to side. And here's our new class. Now let's include eostream string and use the namespace std, and this is a little bit too small here, so let's make it a little bit bigger. Here we go. Note that include has an uppercase I, and this hf macro over here copies everything inside it verbatim, so one-to-one inside the header file. So if you write some crazy stuff in here, you will get some crazy stuff in here. There's one thing you have to watch out for if you use the hf macro, and that is when you use preprocessors within the hf macro. You see that there's a red underline, and it tells me that it does not like hashtags inside the macro. So what you have to do is you have to escape the hashtags. Okay, so let's add a new method. This one. You see that the definition is actually, as always, just with this small keyword here in the front. You could also make it private, and you get a private function. You could make it public static or public virtual. So I hope you see that it's actually the same keyword as always, just but with an uppercase letter in the front. Let's remove that again, so we just have a usual function. Okay, now let's add a variable. Please notice the strange syntax in here, which is totally not C++-like, but that's how things are at the moment. And let's initialize it with a 3. And you see, there was no initialization here. This is because the initialization is done in a different file. Let's open our file explorer for a second, and you see this printer.gen.cpp file open up in here. And then we see that we got a constructor being generated. That's just initializing printing times with a 3. The thing you always have to watch out for here is that the gen.cpp file is inside the list of files that should be generated. Compiled. Creating this .gen.cpp file for generated methods is the standard behavior for method generation. If you rather like to have everything generated in one file, then let's do this. You add a define on top of this one, and what you get is the generation of the constructor inside the header file. Now, it's important to write this define before the corresponding header file, otherwise this will not work. This define here has two purposes. Purpose 1 is it's a switch for cppHeaderGen to tell it that everything should be created in one file, and the other purpose is that it's a protection within C++. What I mean with protection is this if-def protection. That means that this code part is only active if we're coming from the CPP file. This is the reason why it's so important to add it here before the corresponding header file. The important thing to note here is that this first part here is fixed, define gen in header, and everything that comes after it is freely choosable. So you can call it like this. That's no problem. And the thing that's changing is this part here. But our class is called printer, so we just call it printer. Now I'll show you how to create your own constructor. You don't use the user method. Instead, you use the ctor method. This is how it looks like. Be sure that you have a void return type here, not as the usual constructor within C++. Of course, if you want to add a parameter, that's no problem. The parameter gets also inserted here. And if you want to overload it, you can also overload it. What is the important thing? Why do you use the ctor? Because you want to initialize all the variables, and this only happens if you tell cppHeaderGen where the constructors are. So if you use a native constructor from C++, you will not get any initialization. Keep that in mind. But this also means if you want to have a constructor that on purpose does not has any initialization, that should not have any initialization, then just use the good old-fashioned way for making a constructor. For example, I don't know, if you're making a copy constructor. Okay, going on in the list, let's remove that one. If you want to have a method that copies all non-pointer members from one object to another, this is how you do. Generate copy non-pointer member. And you don't even need a semicolon. Let's generate this, and this is what you get. Let's test it and create a new pointer here. And you see that we indeed have a new pointer. We indeed have the initialization for the pointer, but the method does not copy that content because it's a pointer and not a usual variable on the stack. Now, why would you use this kind of method? Maybe because you want to write your own private copy constructor and your C++ version does not support it yet. But for the sake of easiness, let's remove these two again. And let's get a little bit outside the class. The stuff coming now, you can also use in C, not C++, but usual C. If you want to define a global variable, you can do it like this. Just use the global var keyword. And what you get in the header file is an extern int declaration. A new global function looks like this. Just use the def keyword here and you will get a declaration here. And that's it for the syntax. Let's go back into our file structure. And I told you I'm going to explain this one later here. Now, cppHeaderGen over here can only process one file per call. If you want to process a whole folder or a whole directory, you need a script to call cppHeaderGen for every single file. This is just exactly what generate all headers does for you. Let's for once remove this header file. You see it's deleted. And let's run that script. It's written in Python 3. And let's run it together. And you see we get a printer.h. Also see that we do not get a printer.gen.cpp.h. And in case you have a main.cpp, the script will not create a main.h. It's tuned that way. Okay, that should it be for this video. Feel free to leave any comment or question in the comment section. Thank you very, very much for watching, and I hope this helped. Getting familiar with cppHeaderGen.